What if I told you that life on Earth has nearly ended, not once, but multiple times? Throughout history, our planet has faced catastrophic events so powerful that they wiped out the majority of living creatures. These events are called mass extinctions, and they shape the story of life as we know it today. Introduction to mass extinctions. A mass extinction happens when an unusually large number of species vanish in a relatively short period of time. While smaller extinctions happen constantly, scientists recognize 5 major mass extinctions in Earth's history, each one rewriting the rules of survival. Ordovician Silurian extinction. Around 443 million years ago, Earth faced its first great crisis, the Ordovician Silurian mass extinction. It struck in 2 waves and wiped out nearly 85% of all marine species. At that time, life existed only in the oceans. Trilobites, brachiopods, corals, and countless other creatures thrived in shallow seas. But when the supercontinent Gondwana moved over the South Pole, a massive ice age began. Glaciers spread, sea levels dropped by more than 100 meters, and shallow habitats vanished. As the ice later melted, sea levels rose again, but changing ocean chemistry and low oxygen triggered a second wave of extinctions. Entire ecosystems collapsed, and coral reefs disappeared for millions of years. Still, some species survived: early fish, a few trilobites, and resilient marine life. Their survival paved the way for new ecosystems in the Silurian period, proving that even after devastation, life finds a way forward. Late Devonian extinction. Around 375 million years ago, during the so-called Age of Fishes, Earth faced another crisis, the Late Devonian extinction. It wasn't one single event, but a series of die-offs lasting nearly 20 million years, and in the end, about 75% of all species disappeared. The causes were complex. As the first forests spread, plant roots released nutrients into rivers and oceans, fueling massive algal blooms that drained oxygen from the seas. This lack of oxygen, known as anoxia, was devastating. Climate shifts and volcanic activity added even more stress. Coral reefs collapsed and would not recover for millions of years. The armored fishes that once ruled the oceans vanished, and trilobites declined sharply. But some life endured: early sharks, lungfish, and the first 4-limbed tetrapods survived, eventually leading to animals that would conquer the land. The Devonian extinction transformed Earth's oceans forever, clearing the way for new life and changing the course of evolution. Permian-Triassic extinction. After a late Devonian extinction. About 252 million years ago, Earth faced the deadliest mass extinction in its history, the Permian-Triassic extinction, often called the Great Dying. During this cataclysm, over 90% of marine species and around 70% of land species vanished. Coral reefs collapsed, forests disappeared, and many groups of animals, like trilobites, were wiped out forever. Scientists believe the main cause was massive volcanic eruptions in Siberia, releasing enormous amounts of carbon dioxide and methane. This triggered global warming, ocean acidification, and severe oxygen loss in the seas. The after effects reshaped life on Earth. It took nearly 10 million years for ecosystems to recover, and from this devastation, the age of dinosaurs began. The Permian-Triassic extinction remains the closest our planet has ever come to losing nearly all life. Late Devonian Extinction. About 375 million years ago, Earth faced the Late Devonian Extinction, a crisis that unfolded over millions of years rather than a single event. During this time, around 75% of all species disappeared, including many armored fish called placoderms, which once dominated the oceans. Coral reefs also collapsed, and marine ecosystems were severely disrupted. Scientists believe the extinction was driven by a combination of factors: giant plant growth on land pulling carbon dioxide from the air, widespread cooling, ocean anoxia, or loss of oxygen, and possibly asteroid impacts or volcanic activity. The aftermath delayed the rise of new life for millions of years. This extinction cleared the way for new marine predators and eventually set the stage for the rise of early amphibians and the ancestors of modern land vertebrates. The Late Devonian reminds us that even slow, drawn-out changes can transform life on Earth forever. End Cretaceous Extinction. About 66 million years ago, Earth experienced one of the most dramatic events in history, the End Cretaceous Extinction. In a geological instant, nearly 75% of all species vanished, including the non-avian dinosaurs, giant marine reptiles, and countless plants and microorganisms. The leading cause was a massive asteroid impact near what is now the Yucatan Peninsula in Mexico, creating the Chicxulub crater. The impact released energy equal to billions of nuclear bombs, igniting wildfires, sending dust and sulfur into the atmosphere, and blocking sunlight for months. This led to a global impact winter. Temperatures plummeted, photosynthesis halted, and ecosystems collapsed. At the same time, massive volcanic eruptions in the Deccan Traps of India may have worsened the crisis by releasing enormous amounts of greenhouse gases. Yet, from this devastation, survivors emerged. Mammals, birds, and small reptiles adapted and flourished. Without the dinosaurs ruling the planet, mammals evolved and diversified, eventually giving rise to primates and humans. The End Cretaceous Extinction was the end of the dinosaurs' reign, but it also paved the way for a new chapter in Earth's story. Are we facing a sixth mass extinction? Today, many scientists warn that we may be entering a sixth mass extinction, this time caused by humans. Deforestation, climate change, overhunting, and pollution are driving species to extinction at rates far faster than normal. In fact, it's estimated that we're losing species 1,000 times faster than the natural rate. Each past extinction reshaped life on Earth, giving rise to new species. But if we are indeed causing a new one, the future of biodiversity and even humanity itself depends on the choices we make today. Mass extinctions remind us that life is fragile, but also resilient. The story of Earth is not just about destruction, but about rebirth. The question is, what role will we play in the next chapter?